Hi all, 5N1. This is a new topic on magnetism. Before I run through or start the lesson with you, we'll need you to have your notes as well as your pen and or pencil to get ready to fill in any keywords that we highlight, okay, along the way. Let me first of all run through the objective very quickly with you. As you can see, there are A, B, C, D, E, F of objectives to be met for this lesson. So what do you need to know in this chapter? First part of it, part A, state the properties of a magnet. You must be able to describe what makes a magnet a magnet. Okay, how do you convince me that a piece of a metal that you're holding in your hand is a magnet? It must be able to exhibit three properties. So part A, we will learn about that. Part B, you must be able to describe induced magnetism. This is a new term you learn, and we will talk more about it later on. Then next, describe the electrical methods of magnetization and demagnetization. How to turn something into a magnet or to turn a magnet into a magnetic material again. All right, so that's A, B, C. Next will be part D, distinguish between the properties and uses of temporary magnet, for example an iron, and permanent magnets, example steel. So you'll be learning about iron and steel, these two. Then the objective E, that will be to draw the magnetic field pattern around a bar magnet and between the poles of two bar magnet. Okay, very simply these two. And and F will be to describe the plotting of magnetic field lines with a compass. As we go along, the order may be different. Okay, but A, B, C will be mostly the same sequence. And let's quickly start with the properties of magnet. What are the three basic properties of a magnet? Let me pause here for a while to look at the first video clip. All right, in this first video clip, you see a box of iron filing. This plastic box, contains the iron filing in a liquid oil, and you see immediately what happens when we speed up the process. This is the three-dimensional effect. And let me pause very quickly here for a while and tell yourself what you have observed. Okay, I think it's very clear that we see that there are two ends that attract the most amount of iron filing, right? So what must a piece of magnet have? First properties. I think we can see very clearly that the magnetic forces are strongest at two ends. And make a guess, what do we normally name these two ends as? Correct, okay? It's north and south pole. It must have two poles at the end, which the magnetic strength or magnetic forces is found strongest at. Let me now go back to your notes. Okay, so now back to your notes. The first properties that a magnet must have is it must have two poles. And these two poles are north and south poles, and these are the strongest part of the magnet. The poles are found very near to the ends of the magnet, not exactly at the end of the magnet. So even if you tried it out with the paper clips, you know that big number of paper clips can be attracted at this north end and the south end, but you notice that none of them are attracted at the center part of the magnet because that's where there is no magnetic forces. Okay, it is not strong there. In fact, if you put a piece of iron nail here and let go, the iron nail will automatically be shifted either to the left side towards the North Pole or to the right side to the South Pole end. Center part will always attract nothing. Okay, now before we look at the second property, whereby we hang a piece or suspend a piece of magnet freely, let's see what happened. Okay, first of all, this guy will explain with the compass on the table where is the north end and the south end in this room. Okay, then he will suspend the magnet at this place, and you see what happened.
It should point in that direction, and the south pole of the biomagnet should be pointing in this direction. We will see that now. Okay, here is the suspended biomagnet. So it should finally align itself in the direction which we saw before. Okay, to speed up the process, I will just allow it to hang freely. You can see that the north pole is trying to align in that direction and the south pole this way. Okay, we'll quickly, okay, so you can see.
Okay, class, the reason why he wants to use his hand to hold it a little bit is because it takes a long time for a freely suspended magnet to come to a standstill. But no matter how you push the magnet or disturb it or even make it spin, when it comes to rest, eventually it will always come to rest with the North Pole pointing towards the north end of the room, and the South Pole pointing towards the South Pole South Pole of the room. Okay, following the compass. Now, what does that tell you about a piece of compass? What does that tell you about the compass needle? What do you think? Okay, that means a compass needle is also a magnet, because compass needle behave the same way as a freely suspended piece of magnet. Do you get it? You can write that down into your notes, that a compass is actually a magnet. Okay, let me go back to your notes now. Okay, now back to your notes now, yeah? Okay, second properties. So if allowed to swing freely, a magnet will come to rest with one end pointing towards the North Pole, the Earth North Pole. So if it is in a room, you will know where, and with the help of a compass, you know where the North Pole is pointing. Then when you freely suspend this magnet, the North Pole will point towards the north end where the compass was pointing in that room. So the other end, therefore, of course, is known as the South Seeking Pole, South Pole, or in short, the S pole. So in this chapter, you have the right to write in short. If you don't want to write South Pole in full, you can write S, then dash with the pole, or in short form. Now we look at the third properties. Okay, just a reminder again, altogether there are three properties. So the next point. Now, what is this third properties? I think it's something that you are very used to playing with a piece of magnet. Every time you hold a piece of magnet in your hand, you want to test it out whether it will attract something, right? So what do we call the things that are being attracted by a piece of magnet? So when it's attracted, what do we call them? So let's look at this third point. We call this the magnetic material. Magnetic material can be made into magnet. Other magnetic materials, other materials that cannot be attracted, therefore are called the non-magnetic materials. Okay, and just to have you know that there are four types of magnetic materials named on this earth. I give it a short acronym, NICS, NICS. There are only these four categories of magnetic materials, and you have to know them by heart. Any other thing that does not belong to NICS, they are non-magnetic. So let's fill in the left column of your table. First of all, N stands for nickel, I stand for iron, C stand for cobalt, and S stand for steel. Normally, student has no problem with nickel, iron, and steel, but sometimes C, some students have a tendency to think that it is copper. It is not copper, it is cobalt. All right? Now, how about non-magnetic materials? Non-magnetic materials, I think we have a wide variety of them, okay? Many. Just to give a few, we have wood, plastic, rubber, right? So glass, for example, all these are non-magnetic. Maybe there are some that uh, students that may still have misconception is that they tend to say that all metals are magnetic, all metals can be attracted. That's why I leave point form blank for a while and make you think, okay, to let you think, are there things that are metals but yet cannot be attracted by magnet? Let me pause here for a while and show you a video clip very quickly again. Okay, class, let's take a look at this video clip on some metals that are being tested, and I will check with you what you observe. Are all metal elements attracted to magnets? Iron, aluminum, magnesium, titanium, tin, cobalt, zinc, lead, copper, nickel, gold, silver, platinum. So nickel, cobalt, iron. Notice steel is not within here, but steel can be. Let me go back to your notes now. So what is this fourth point that I want to emphasize? That not all metals are magnetic. And if they are not all metals that are magnetic, who are they, right? As we have seen from the video clip just now, they are the copper, zinc, brass, aluminum, and if you can recall, also platinum, gold, right? And just try your best to remember that it is only this nickel, iron, cobalt, steel that are magnetic, while the rest are not. Okay? Now, at this point, um, if you have a piece of magnet, which sometimes you can find at the on the fridge door, sometimes you have some paper, this magnetic uh, figures that you attach to the refrigerator door. Just take one of them and try it on all the Singapore coins, new ones and the old one. You will notice that some of the coins cannot be attracted, and these coins probably are made of copper. Some students sometimes ask, what if it's an alloy? Meaning it's a mixture of metal. Now, so long an alloy has some element of magnetic material in it, for example, copper with a little bit of iron on it or steel in it, then this alloy would be able to be attracted to a piece of magnet. Okay? Okay, class. At this point, let's consolidate what we have learned so far. Part A of the objective of the lesson is to uh, be able to describe the three properties of a magnet. Okay, and in these three properties, one of them we have learned is that uh, a piece of magnet must be able to attract magnetic material. And who are these magnetic materials? Remember, you must be able to recall the magnetic materials are none other than the four NICS: nickel, iron, cobalt, steel. Now, just to let you see how some of these questions may appear in the O level, um, you can now quickly turn to the worksheet behind the notes. Okay, take a look at the worksheet behind the notes, and I would like you to flip to the question behind this page, and let's look at the let's look at question 14 and 18. Can I give you a minute to quickly do these two questions that I run through, confirm the answers with you? You can pause the video clip here and do your work now. Okay, class, let's confirm our answer now. I think you will be able to very quickly verify the answer with me that the first one, number 14, which of the following materials can never be picked up by a magnet? Okay, can never be. Let me enlarge this. Okay, can never be picked up. So I believe the answer is B, right? Can never be. All right, now let's look at question 18. Which of the materials, that means both of them in A, B, C, D, in this process are non-magnetic? Okay, non-magnetic. So I can see that the option B will be the best answer, would be the answer as well. Okay, so that's how some questions can be asked about magnetic materials. These are part of magnetic properties that you have learned in objective A. Let me pause here again. I will now come back to your notes.